Alright, good morning everybody. Here we are. We're at the Studying Snakes Population part of this packet. Alright, this is all section 3.2 of our packets. This is right before growth factors and growth rates. Alright, this is day 4 of this packet. And let's see what we got here. So we're studying the snakes, interpreting graphs of exponential functions. So we have an exponential function. Some things are going on here. We're talking about the growth of this garter snake, and we're going to figure out a few things here, write a few equations, and answer some questions. So we have an exponential function here, right? And number 1 here says find the snake population for 2, 3, and 4 years. So if you run this, if you look at the y-axis, it's going up by 25s. The x-axis, all right, it's going half, 1, 1/2, 2, and so on. And if you look at these coordinates, this is 225. You have another coordinate here, 3, 125, and then you have another coordinate here of 4, 625. And what I'm going to do is I'm going to fill in the table for 2, 3, and 4. So we got 2 is 25, 3 is 125, and 4 is 625. All right. So we have 3 coordinates given to us from this graph, and the coordinates I really want are the y-intercept to help me write my equation, which is not given to me, but given these 3 coordinates, given the fact that this is an exponential function, I can get down and figure out what that y-intercept is going to be here, right? So the y-intercept, again, is always going to be where the x value is 0. All right, so let's see how we do that. So if we notice, to get from 25 to 125, you're going to multiply by 5. Now, if that didn't come easy to you to find what you're multiplying by, well, here's what you think about. Well, 25 is going to be multiplied by some number, right? Some number x, and this is going to give me 125, right? So 25 times something will give me 125. Well, 25 times what will give me 125? So this is just a one-step equation. And you can do it very easily like this, and you can do x is equal to 125 divided by 25. We'll think about how many quarters are in $1.25, and the answer is 5. So my growth factor is 5. Okay. So now I can verify this again. If I do 125 times 5, I should get 125. So I keep multiplying to keep going down as my years increase, or you could go up if you do the opposite of multiplying. Well, what's the opposite of multiplying? Well, I'm going to work backwards, and opposite of multiplying is dividing by 5, and I could divide by 5 and get backwards. So what's 25 divided by 5? And that should be 5. And if you verify this again, is 5 times 5 25? Yes. Is 25 times 5 125? Yes, and so on. And then I could do this one more time, and so what times 5 is going to be 5, or 5 divided by 5 will give you 1. Right? So you could always work backwards. So now I know my y-intercept here, and this is my a value in my equation f of x equals a times b to the x. So now I have my a. I know my b, right? So my a value is 1, and my b value here is 5. And I'm sure in these next couple of questions they're going to ask me to write an equation, but you have everything you need now to write the equation. So let's keep going. Explain how you can find the y-intercept, all right? And that's exactly how what we just did is how we found the y-intercept, right? So we worked backwards on this table. We were given 3 coordinates, great. From those 3 coordinates, I was able to get the growth factor and work my way down. Now that I know my growth factor, use the opposite of multiplying, divide and go backwards. So 25 divided by 5 is 5. 5 divided by 5 is 1, and you get down to 0. And I'm going to stop at 0 here because this is my y-intercept. And that's all I need to write my equation. The growth factor and the y-intercept. Alright, explain how you find the growth factor. Alright, so we just did that and that whole explanation there again. Alright, but again, if you're confused of how to get your growth factor, you write down your 2 numbers here. So I did 25 is getting to 125 somehow. Well, I'm multiplying 25 by something, and it's going to equal 125. How do you get there? And this will work for every problem, okay? And then you get your x is equal to 5. And we'll see some more problems as we move on and get some practice problems in. They're not always going to be nice, easy numbers like that, or something you can do mentally. Some of them are a little more challenging. But if you stick to this little piece here of how to find it, it will always work. All right? Write the equation, cool, relating relating time t in years and a population. So P of t is equal, right? T is always going to be independent. So I got P of t equals A times B to the t power. We identified A as being 1. We identified B as being 5. And that's all you need. So P of t is equal to 1 times 5 to the t power, excuse me. All right, so P of t equals 1 times 5 to the t power. Now I keep writing this 1 here, but at some point, if you just wanted to write P of t equals 5 to the t power, that's fine too. All right, multiplying by 1 is not going to change anything in the equation, so either form is acceptable. All right, so now we have the equation, and of course now we have the equation, I'm going to ask you to use the equation. So what am I going to do, or what am I going to ask of you? All right, so one of two options. I'm going to give you what P of t is equal to, and you're going to find t, or I'm going to give you t, and you're going to find P of t. All right, so those are two options you have, two variables, so I can give you one of those two things. So in what year, so I'm asking the year, is the population likely to reach 1,500? So what am I giving you here? Right, am I giving you the year? Am I giving you the population, the P of t? So the year is t, the population is P of t. What am I giving you? So I'm asking what year, so I'm not giving you the what year, I'm giving you the population. So 1 is P of t equal to 1,500. So if I substitute in, so when does 1,500 equal 5 to the t power? All right, and now I'm going to resort to using either Desmos or my graphing calculator. And I posted a video. I showed you guys a quick video that I posted in Google Classroom on how to find the TI-84 calculator online. We're going to use NJSLA practice tests. So please watch that video if you have not watched it. I'm going to bring up the TI-84 calculator now, and I'm going to do this on the TI-84 calculator. So we have these two equations. We have 1,500 equals 5 to the t power. So again, so y sub 1 is going to be 1,500, and it doesn't matter which one's which. And y sub 2, I'm going to make 5 to the t power. I'm going to graph these two equations. One's going to be exponential, one's going to be horizontal, and they're going to intersect somewhere. And that point of intersection is the t value that I'm looking for, right? Find t. Okay, well, I want the t value of where they intersect, right? So here's my calculator. So I'm going to type in 1,500, 1500, go down, and I'm going to do 5 to the t power. So I'm going to use the caret button, 5, and it doesn't have t, but I'm going to use x, right? It's just a variable. All right, so I'm going to have those two equations. Now I can hit graph now, and most likely I'll see that one graph, but I won't see the 1,500. And if you think about why I don't see it, and if you're thinking that my window is not correct, then you're right? This window, the x value goes to the right 10, left 10, down 10, up 10, right? I need this to go up to 1,500. So window, x min, x max, I'm okay with that for now. Y min, I don't care how low you go. I'm curious, I just want to know how high you go. So it's set to a height of 10, and I know I need 1,500, so I'm going to change this to above 1,500, so I'm going to put 2,000 and see what happens. And then I'm going to hit graph. So there's my exponential function, there is the horizontal line, and now they're intersecting. On Desmos, you could click on that point and it'll tell you. All right, with our graphing calculator, we're going to do a little bit more, and here's how we do it. So if you see here, it says calculate in blue. So first I'm going to hit second, calculate. Number 5 is the intersection, so 5. And it brings me right back to my graph, and it says first curve, question mark. I'm going to hit enter. Second curve jumps on the exponential function, so I want the first curve and the second curve, and then it says guess. Let's not guess and just tell me. And here's the intersection of 4.543 and change. So I'm going to steal this picture here, come back to my screen here, extend this page a little bit, and post this here. Excuse me. So where's my intersection, and what year? when t is equal to 4.54 dot dot dot. So about 4.5 years is when this will happen. Or, and if you want to say, if you want to round up, in the 5th year, it will start to happen there. Okay, so this will give me exact answers. But again, if you round it to t equals 5, that's fine. But either one of these is going to be okay. Alright, so that's the first 6 problems on that page of studying snake populations. Alright, and then you can turn your page to number 7. Alright, so it's all studying snake populations, letter D. And then here's the next piece here. So let's take a second and read this to ourselves. If you guys were reading that, I got to pause my video here and give you guys a little chance. And I actually had a cookie while you guys were doing it too. Compliments of my wife. So, all right, back to Amy and Chuck here. And it says, Amy says it's not a function. Chuck says it is a function. Amy says it looks like there's more than one dependent value associated with it. And Chuck says it's difficult to read. I don't know, but here it is. So here's our graph. If we run this all the way up, if I drew my vertical line somewhere, sure, we'll throw it right there, and we just drag this line through. It looks like it only hits one point at a time on the entire function, so it looks like it passes the vertical line test. And the fact that I'm telling you that this is an exponential function might be a little hint that looks like Chuck's going to be the winner here. There is only one output for that input of 4. All right, so however you want to say that, that's fine. An explanation, and then who is incorrect, and so Chuck Norris wins. Just joking, just Chuck. And Amy looks like she's gonna go back and correct it. No big deal. All right, so there's number 7, and then we got this exponential function form here. All right, this is a nice little wrap up. I like this. All right, so what you should be getting from these first couple pages here. What pieces of information do you need to write an exponential equation? All right, so hopefully, so if I say, what is a linear equation? You should be thinking y equals mx plus b. What's an absolute value equation? So then you should be thinking y equals a times the absolute value of x minus h plus k, or your very basic y equals the absolute value of x. And now, what is an exponential function, okay? So y equals a times b to the x, and we're going to stop it right there, right? We're not going to mention the h or k like I've said in the past videos. We're just going to stop it very nicely right there. Y equals a times b to the x. And what do you need? You need a, which is your y-intercept, and we need b, which is the, good if you said it, growth factor. So those are the 2 pieces of information. How do you find the growth factor from the table? Well, if we look at the last example we did, right, as your table increases, let's make that a little neater here. We'll put it here. So the last table was 0, 1, 1, 5, 2, 25, right? What's the growth factor? Well, how much are you growing? How are your y values growing? And they're multiplying by 5, therefore that is my growth factor. How do you find the y-intercept in the table? Well, the y-intercept again is going to be wherever your x value is 0. Whenever you have an x value of 0, then that's your then the corresponding y value is your y-intercept there. All right, and then what does the exponential function look like? Let's just go back a screen, and it looks a little bit like, let's see, hold on. Just joking, and I want to go back, and it looks just like that, right? So this is your exponential function screen. This is your exponential function. All right, and you know what? Why not? Let's go. I'm going to go to basic. Let's go to this one, y sub 2, and I'm going to do zoom. If I go zoom 6, it brings me back to my standard window, and that's it. What does it look like? It looks like this right here. All right, there's your exponential function. We'll take that. Let me just take one more picture of that. Come back to my screen here, and what does it look like? It looks like this right there, right? There's your exponential function. All right, this is your basic. This is the exponential function we just did of y equals 5 to the x power. It's actually 1 times 5 to the x power. This is your y-intercept of 1 and 1.5 to 25, which you can't even see in this graph, right? Because this only goes up to 10. All right, so there's your exponential function. And then if we recall, let's recall this a little bit. This function never crosses that line there. It never crosses the y equals 0 line because, and if you remember, there is a horizontal asymptote located there. So this line, this exponential function, will not cross a horizontal asymptote. All right, and then as you get further and further in that algebra, you'll see that these horizontal asymptotes help us graph, much more complicated equations, and then you'll have something else called vertical asymptotes. But we'll leave that for 2 years from now. All right, so at this point, I'm going to put all this on Hello Smart. I'm going to create a blank page at the end of this growing mold piece. And what I would love for you guys to do, at the end of this studying snakes piece, before going into growth factors and growth rates in your packet, I'm going to post a blank screen there. I'll make a collaborative. You guys can all go in and post a question. Again, just hit the letter on the side and type away. All right. If you're not comfortable doing it there, you could email me or you could post a question on Google Classroom. And if there's enough questions on these first 3 topics, I'll make a video on all those questions, and then post that video on Google Classroom or whatnot, and then I'll start growth factors. So good luck. Please let me know if you have any questions. Talk to you guys soon.